Hello, everyone. This is a walkthrough to create your own basic network topology simulation of a small enterprise network using Cisco Modeling Labs, or CML. We'll be using the personal license because our topology includes FTDv, or Firepower Threat Defense Virtual, and the image for it is only available in the paid version of CML, or if you have a support contract. CML Personal costs $200 per year, but it's a good product and worth the investment. For this lab, I recommend you run CML on a VM with a minimum of 16 gig of RAM, 8 vCPUs, and 70 gig of disk space. More is better if you can spare the resources. I am running mine with 100 gig of RAM, 10 vCPUs, and 400 gig of disk. My CML VM is intended for more resource-intensive labs. Topics we will cover include basic web server setup using Alpine Linux, standalone Cisco Firepower Threat Defense Virtual or FTDv setup, and basic NAT or network address translation. Let's get started. If you need help setting up CML, I put a link to a video guide in the description. First, in your CML dashboard, click on Add in the top right. Then in this top menu, select Add Nodes. You can hover over a node to see its description. So this is a useful description. It says that when it's configured in bridge mode, the external connector will be placed in the same network as the CML appliance. That's good. That's my private home network. That's where we want it. So we'll use the external connector. Then left click it. In the config tab, change the connector selection to be system bridge. So that means anything connected to this will be on the same subnet as my CML VM and my home network or my home PC. Next, let's add an unmanaged switch. This is a simple layer 2 switch that cannot be configured. It's just there for port density. Next, we'll also add an Alpine Linux node. It's pretty lightweight, 512 MB of RAM, 1 vCPU, and 16 gig of disk space. So this will be it will simulate our external server. Let's right click the external connector, select add link, create a link to the unmanaged switch. Then we'll create another link from the unmanaged switch to the Alpine Linux node. Next, we need to add an FTDv or Cisco Firepower Threat Defense Virtual. This is their firewall. It requires 8 gig RAM, 4 vCPUs, and 32 gig of disk. But I had to find the disk by looking at Cisco's website. This will be on the boundary between our DMZ and our internal subnet. So I like to draw a line here to serve as a delineation point. We'll increase the thickness and we'll change its color to be red. We'll add an annotation up here. We'll call it DMZ, and the subnet is 10.0.0.0/24. That's my home network. You should assign IP addresses according to your network. So if your network is 192, then you should use that subnet instead. We'll duplicate this or clone it, and we'll move it down here, and we'll call this one internal. This will be 192.168.1.0/24. Next, let's add a link from the DMZ unmanaged switch to the FTDv0. This will be our outside data interface. So we do not want to use the management port. we'll use G00. Next, let's add another switch. It'll be our internal switch. Let's add a link from the FTD to the internal unmanaged switch. We'll need to manage it. We want to manage it from our internal subnet. Generally, you wouldn't want to manage it from your DMZ just for security purposes. So we'll use management 00. That's good. We'll add another link. This will be our internal data link. Sometimes FTDv defaults to this interface of do not use. So do not use that port. It does not work. We'll use G01 for our internal data interface. Next, let's add another Alpine Linux node. This will simulate our internal web server. We'll add a link to the unmanaged switch, create link. And finally, let's add a Firefox node in the internal subnet. This will be used to test and manage our FTDv0. Let's right-click the unmanaged switch and add a link. So this is our basic network topology. Let's add some more annotations so we have our IP addresses. So we'll add 10.0.0.1 is my home router. So the external connector is representing my home router, but in actuality, the external connector is connected to the CML VM, which is on my PC, which is then connected to the default gateway of my home router. But we'll just represent it with one hop here as 10.0.0.1. Next, we will clone this and we'll put an IP address for the DMZ server. We'll say 10.0.0.130. When you're assigning IP addresses, you should go into command prompt to make sure that the IP address is free. If I try and ping 10.0.0.130, this IP address is my PC and it's saying the host is unreachable. That means the IP address is probably free. You can also use a higher number in your DHCP range that will help you avoid IP conflicts. So that one seems to be free, so we can use it. We'll clone this. For our FTDv, we need an outside IP address. We'll use 10.0.0.118. We need to clone this. We need an inside IP address now. We will use 192.168.1.1. Again, you should adjust this according to your network. So you may need to use different IP addresses. When I try and move this up here, it's hard to read. So if I click this gear icon and then the magnet, I can disable snap to grid, which will allow me to move this freely. Then I like to re-enable snap to grid because I actually like it most of the time. Let's clone and add another IP address. This will be our management for FTD. We'll use, it should be in our internal subnet, v192.168.1.117. That should work. And we'll turn off snap to grid so we can move it. That looks good. Let's clone this again. This is our internal web server. We'll use 192.168.1.130. So the fourth octet is identical to the DMZ server. We need one more IP address. We'll clone it. This will be our Firefox. We'll use 200. That's just arbitrary. You can, again, you should make these IPs whatever you want them to be. Now we've got our annotations and all of our nodes set up. We should change the names of our servers so we know what they are. So let's change the display name. If you left click it and then click settings, we'll call it DMZ server. Let's change the display name for the internal server. We'll call it internal server. We can also change the display name for the unmanaged switch. So we'll call it DMZ switch. And we'll change the name for our internal switch. We'll call it internal switch. Okay, don't get trigger happy. We're not starting any nodes yet. On DMZ server, left click it, then go to the config tab. This is a shell script that will be sourced at boot. That means every time this Linux node boots up, it will load this configuration. Anything with a pound sign in front of it is a comment, and it will not be part of the configuration. So first, it will create a host name, which is insert host name here, which is catchy, but not very useful. So we will comment this line out with a pound sign. Then it will configure a user account named with the username of Cisco and the password of Cisco. We don't want that either, so we'll comment those lines out as well. Then click Save. Then right-click the node and click Start. We'll also start our DMZ switch, and we'll start our external connector. These are all lightweight nodes, so you can start them all at the same time. It will not overwhelm your PC or your server. The FTDv is a heavier weight node, and if you had many of them, you should probably stagger the starting of them so they don't overwhelm your PC or server. Now the DMZ server is up, you can right-click it, select Console, open Console. The host name is localhost. That's good. It's better than insert host name here. We will configure this server manually using Linux commands. To log in, the username is root. There is no password. It logs in after you type in the username. We will set a static IP using this command. VI stands for Visual Editor. It is the default text editor that comes with Linux. We will be modifying the interfaces file, which is located in the etc/network directory. Use the arrow keys to move your cursor around. When you're ready to edit, press the I key. That will enter edit mode. Then use your keyboard to make the necessary changes. So we'll set this to static instead of DHCP. The address will be 10.0.0.130. The net mask is 255.255.255.0, otherwise known as /24 in CIDR notation. The gateway is 10.0 to 0.1, which is my home router. When you're finished editing, press Escape to exit edit mode, then press Shift, then WQ. That stands for Right Quit, then press Enter. We can verify our changes to that file using the cat command, which is short for concatenate. That looks correct. Now, if we use the IP address command, we can verify our IP address. we need to look at Ethernet 0 as it is in our diagram. So this is Ethernet 0. This is the loopback interface. Ethernet 0 says it's got an IP address of 10.0.0.81. That's because it's using DHCP to get an IP address from my home router. It hasn't changed it to this static IP address yet. To force the change, we need to use this command, rc service networking restart. Then if we type IP address, or IP add for short, we can see the IP address has changed to 10.0.0.130. That's good. Let's do a quick test by pinging to my home router. That's successful. That's good. We can change the host name by using this command. Echo will write anything that is in the quotes, that is in quotations, will be written to the file you specify. So we'll call it DMZ server. We want to write this to the etc hostname file. Then if we want to force our Linux node to change the hostname while it's still running, we can use this command. And you can see our hostname has changed to DMZ server. Next, let's try pinging the internet. We'll ping Cloudflare's DNS server, and that's successful, so that's good. Let's test our DNS by pinging Google. That's not successful because it's using IPv6. So we need to disable IPv6. To do that, we can use this command. By the way, you don't need to use sudo. I'm just using it out of habit. Sudo stands for super user do, and it's used to escalate your privileges if you are not signed in as the root user. You can check who you are signed in as by typing who am I, and it tells me that I am root. I am root. So because I'm root, I can run these commands without using the sudo command. We will edit this file. sysctl is for system control. The content of this file will override this other file. That's okay. That's just a commented line, so we can delete that. Then we need to paste in this command. I will put it in the description. Then press escape. Then Shift:\WQ for right quit. Then we can check our change to that file using concatenate. That looks right. Then if we do the IP address command, we still see IPv6 addresses here. So we need to update our Linux config to use that file. It's not currently using it. So we'll use this command. And you should see this. Now let's check our IP address again. And IPv6 is gone. That's good. So we are totally IPv4 now. Let's test with a ping to Google. And that's successful. That's good. Another way you can verify your DNS servers in Linux, it is in this file, resolve.conf. These are DNS servers that were acquired from the DHCP service on my home router. That's where it got these. Next, we need to start our FTDv. We'll start this because it takes about 5 minutes for it to load up. So while we're loading that, while that one's starting, in our DMZ server, we'll set up our web server. We'll use this command, apk add light-tpd. Light-tpd is a combination of the words light and HTTPD, which is a lightweight web server. I'll put a link to its documentation in the description. After that's done, you use this command to update it. Then we'll restart the light-tpd service with this command. Next, we need to create a basic web page. So we'll use this command. I will put a link to it in the description. By the way, I had to link the configurations in the description to my Proton Drive because YouTube does not allow placement of angle brackets in their descriptions for security purposes. So once you get the command copied, you can right-click and then select paste. And let's look at what this command is doing. So it's an echo command. Anything in the quotes will be written to this file in var /www/localhost/htdocs, and then it'll be written to an HTML file. It is HTML code with a doc type of HTML. It's got a title with a check mark. It's a little hard to see here. And then it's got a body that says light TPD is running. So we press enter. Then if we use cat, we can check that. And that looks correct. Now that our HTML page is set up, we can try connecting to it. From my PC, I will connect to 10.0.0.130, and it says light TPD is running. That's great. So we know that's functioning correctly. If you're having difficulty connecting to your web server or any nodes in your CML lab, you may need to modify a Windows firewall setting. So click Start, then type Firewall, then select Allow an app through firewall, then press V to go to Virtual Machine Monitoring. First, you need to click Change Settings, then check it, and check Private and Public, select OK, exit that, and then retry the test to your web server, your DMZ web server. By the way, you may want to use an in-private window because the regular browser caches the response from your web server. So this is not caching the response, so we know that the web server is working properly. Next, I would like to test the persistence across reboots for our DMZ server. So in DMZ server, you can use this command, sudo reboot. This will reload the server. We can see the login is still showing us the host name is DMZ server. That's good. We can verify our settings by pinging. So ping the default gateway. We'll ping Cloudflare DNS, and we'll ping Google. And those are all successful. That's good. Let's do another test to our web server. But again, we'll use the in-private window so our results are not cached. And that's successful, so that's good. So all of our settings have persisted across reboots for DMZ server. Next, we'll configure some basic settings on FTD. So right-click it, select Console, open Console, admin, the user is admin, the password is capital C, lowercase ISC 01, then the @ symbol, and 3. We will configure a management IP using this command. Manual means static. The management IP that we used in our diagram was 192.168.1.117. If you type question mark after, it will tell you what you need next. Next, we need a net mask. It will be 255.255.255.0. And now we need a default gateway. So we'll use 192.168.1.1, which will be the inside data interface on our FTD. Press enter. Now let's also change the host name. We can check our configuration changes using this command. So now the host name is FTDv0, and the IP address is 192.168.1.117 with a default gateway of the inside interface on the firewall. We can also verify our other IP address interfaces using this command. So G00 actually has an IP address that was given to it by my home router. My home router is just a standard router that you get from your ISP. And it's using DHCP. We'll change that in a minute. Then gig01 uses this IP address by default on FTDs. .45.1. We'll also change that. You'll notice management 00 surprisingly says it's unassigned. This is actually incorrect. The IP address that it is assigned is right here in the show network command. Now that we've verified our IP addressing for our management, let's use the Firefox node to access the GUI. Left-click the Firefox node, then in the Config tab, this is a shell script that will be sourced at boot, otherwise known as a bootstrap config. We'll need to remove the pound signs from lines 2 and 3 so that these configurations do take effect. We need to change the interface to Ethernet 0 as it is in our topology. And we'll change the IP address to be the same as it is in our topology. Line 3 will make sure it comes up. We'll add a default route. It points to the inside interface of the FTD. We'll also add DNS servers. So we'll use this command. This is Google's DNS server, and we'll write it to this file, etc/resolve.conf. Then click Save. We can right-click our Firefox node and start it up. We'll also right-click the internal switch and start it. Do not start the internal server. We will configure that later. On the Firefox node, right-click it, select VNC, open VNC. We need to use the IP address, the management IP address of our FTD. So it's 192.168.1.117. You'll notice this is not working. Also recommend right-clicking the title bar at the top and unchecking hide toolbars so it doesn't keep collapsing that. We need to change this to HTTPS. That's why it wasn't working before. Ignore the security risk. It's only showing that because it's a self-signed certificate, so accept the risk and continue. We use the same credentials as before. At FTD always opens its GUI, or Firewall Device Manager is the name of the FTD GUI. It always opens with this configuration wizard. So we need to set the outside interface address. So we'll make it static or manual input 10.0.0.118/24 with the default gateway of my home router. Click next. By the way, you can make this bigger if you right-click the title bar and select Open Full Screen. We'll set our NTP server. I'm in America in Eastern Time Zone, which is Detroit, so we'll use that. That's good. We'll use the default NTP servers. That's fine. Click Next. They force you to register with Cisco Smart Software Manager. So you can use the 90-day evaluation period without registration. The performance tier will just use the lowest since this is a lab and we don't need many resources or high speeds. Then click Finish. The device will be a standalone device, so select that. You can click Got It, or you can click Configure Interfaces or Configure Policy. We want to configure our interfaces, so we'll click that. The outside interface is correct, but as we showed earlier, the inside interface is incorrect, so we need to change this. At the bottom, there's a scroll bar. It's a little hard to see, but if you scroll to the right and then click Edit, you can change the IP address. So we'll change it to 192.168.1.1/24. This over here is creating a DHCP server on this interface. We only have a couple of devices on our inside subnet, so we'll go ahead and delete this. We'll just manually assign the node's IP addresses. Click OK. Now the inside Ethernet gigs Ethernet 01 is correct, and the management IP is also correct. We can see that in our URL title bar. Nothing has happened until we go up here to this deployment icon and click Deploy Now. While it's deploying, it gives you this, you can click OK, but I prefer to keep it on this window until the deployment is complete. Okay, mine took about a minute to deploy the change. Then click OK. Then we'll go to Policies at the top. This is our default policy that comes with the FTD. So you can see there's this first one, which says that it will trust any traffic from the inside zone to the outside zone. That's a pretty good policy to have. That'll help us connect to the internet. Anything else is subject to this default action of block. Well, we don't want traffic from the DMZ to the internal subnet to be blocked, so we'll change this policy to be trust, or we'll change the default action to be trust. Click OK. Then deploy the change. Mine took about 30 seconds to deploy that change. Press escape to exit the full screen. Then let's have a look at our diagram. As I mentioned earlier, my home network is using the ISP provided router from Xfinity. Because of this, it is only NATing the 10.0.0.0/24 subnet. It is not performing NAT for the internal subnet. So any devices that are on the internal subnet cannot reach the internet because there is no NAT being performed at my router. To resolve this situation, I could buy a more robust router, but I'm too cheap for that. So we can configure NAT on the FTD. Let's look at our Firefox node. We'll use full screen. Let's try opening a website. I was actually able to access google.com. The reason for this, if we look at our FTD and under security policies, there's a NAT checkmark here. If you click it, it shows us that there is already an existing NAT policy. This is included by default on FTD. If you click edit, we can see what it's doing. The title is Inside Outside NAT Rule. That's a good description because it is taking anything from the inside subnet, any IP address, and it's translating the source address to the interface IP of our outside interface. So back in our diagram, anything on the 192 subnet is being translated into this IP address, 10.0.0.118. As such, when Firefox browser is reaching out to the internet, the initial source is the 192 subnet, but then it is translated to the 10.0.0.118 subnet. When it gets to the default gateway for my home network, it is then NATed to a public IP, goes to the public IP address, comes back, is translated back into this 10.0.0.118, which is directly connected to my home router. Then the FTD is translating 10.0.0.118 back to 192.168.1.200. So we actually do have internet connectivity due to this default NAT rule on our FTDv. That's great. However, if I want to connect from DMZ server to the Firefox node, it will not work. Let's test. Clear this. That's not working because there is no NAT rule to translate our outside subnet IP addresses to the inside interface IP address. So to fix this, we can add another NAT rule in the FTDv. We'll go to our Firefox VNC. We'll open full screen. Then we'll click add a NAT rule. We'll call it outside inside. It will be a dynamic NAT rule. The source interface will be from the outside. The source address will be anything in the 10 subnet. The destination interface will be the inside interface, and we'll use its IP address. So anything from the 10 subnet will be translated to the interface IP address of our inside interface, which is 192.168.1.1. Then click OK. Don't forget to deploy the change. Click OK, then escape this. Then let's go back to our DMZ server and we'll retry that ping. This is still not working. This is because DMZ server does not have a route to that subnet. So if we do the IP route command, you can also use IPR for short. It's only got a default route towards my home router. We can also use this command to see what route it will use for the 192 subnet. IP route get 192.168.1.200. It will send it to its default gateway, 10.0.0.1. The problem with that is that my default gateway is a standard ISP router, and it does not allow the addition of static routes. Therefore, in the DMZ server, we'll need to add a static route using this command. So the DMZ server will be able to reach the 192 subnet via the outside interface of the FTD. We'll check our routes again using this command, IPR. And now we have a route to the 192 subnet. Let's test by pinging. That's successful, that's good. Okay, you'll notice I've encountered a rendering error in CML. If this happens, I close this window, then I right-click the node I was just consoled into, console back in, open console, and that display issue is resolved. If I want to, let's suppose I want to manage the FTDv from my PC instead of from the VNC viewer in the Firefox node. So to do so, I will need to add a route in Windows. So I opened a command prompt window using administrator privileges. Then I entered this command. That's the destination subnet, and its gateway is 10.0.0.118. It says OK. Let's go ahead and test by pinging to the Firefox node. That's successful, that's good. We should be able to open a GUI session to the FTD, otherwise known as Firewall Device Manager, using HTTPS. We can accept the risk and continue, and we can log in. This is much nicer. We can see the full screen now. Okay, back in our topology, we'll configure the internal web server. I saved this for last because we needed to have a connection from the internal subnet to the internet so that internal server could use a shell script to download its web server. So we'll left-click internal server, then go to the config tab, copy and paste the config I provided in the description. Let's review the config. It gives a host name of internal server, it gives it an IP address, it gives it a default gateway and DNS servers. Then it disables IPv6. It downloads light TTPD, updates it, and restarts it. And it creates this HTML web page. It's a little bit different from the DMZ server. It says light TTPD is running on internal server. Click Save. Then right-click internal server and start it up. That took about 20 seconds. Now we can right-click internal server, select console, open console, log in as root. The host name is correct. Let's check the IP address. 192.168.1.130, that's good. There is no IPv6, so that's a good sign too. Let's test by pinging to my home router. That's good. Let's ping to Cloudflare DNS. That's good. And let's ping Google. That's also successful. That's great. Now let's test a web connection, an HTTP connection from my PC to the internal web server. We'll use an in-private window. And that's successful. Light TTPD is running on internal server. That's great. We can also do a ping from internal server to DMZ server. That's successful. That's good. Let's do a ping from DMZ server to internal server. That's also successful. That's good. On our FTD, we can actually see our NAT translations using this command, show xlate, which is short for translate. So we can see here's a UDP to port 123, that's NTP. So the management interface on our firewall is reaching out to an NTP server via the outside subnet. Then these are our pings, ICMP, from the external server, the DMZ server, to the inside was translated to the inside interface IP address. And from the inside, our inside server was translated to the outside IP address. We'll also do a test from our Firefox node to our DMZ web server. So from here through the firewall and to the DMZ web server. It's 10.0.0.130. Light TTPD is running, and we've got the check mark as our title bar. That's great. Now that we've configured full connectivity on our network, let's make it a little bit more realistic by creating some blocking rules on our firewall. So from our FTD GUI, or the Firewall Device Manager, FDM, click on Policies, Access Control. Remember, we have this default rule that permits any traffic from the inside zone to the outside zone. It trusts it. That means it allows it through without inspection. That's okay. We can leave that rule as is. Our default action is also trust. This is obviously not good security. So let's change it to block. We'll also enable logging at the beginning and end of the connection. So any traffic that is not coming from the inside to the outside will be subject to our default action of block. So in our topology, anything from the DMZ to the internal subnet should be blocked. We need to deploy the change. That took about 15 seconds. Click OK. Then we will be kicked off the FDM because I'm accessing it from my PC and we just blocked that traffic. So to re-access the FDM or the FDM GUI, we need to go back to our Firefox node. Then go to Monitoring, Events, and we have many connection events now because we turned on logging. You can see the majority of them are trust. We'll pause it so it stops loading new events. Most of them are from the management IP of the FTD, and they're reaching out to various Cisco services. Now let's try a connection from my PC to the FDM, and we'll see if that results in a blocked connection. We'll click resume, and we'll refresh this page. It should be blocked, and it is timing out, so that's good. Go back to the VNC. Here we go. Just needed to load. Okay, and we have some blocking events now. We have blocks from my IP address. This is my PC to 192.168.1.117, which is the management IP of the FMC. So that's great. We're seeing blocked events. If I try to ping the Firefox node again, it's blocked. That's good. That's what we were expecting. However, if we look back at my topology, let's say the DMZ server is an external web server and we want it to communicate to the backend database, which is hosted on our internal server. We should allow that traffic. So back in our firewall, we can create a more specific rule to permit certain traffic. So we'll go back to our policies, access control. If we scroll to the right, there's a plus icon here. We can add a rule. We'll make it allow. Allow means the traffic will be allowed after inspection determines that it is safe. We'll call it outside to inside. The source zone will be the outside zone. The destination zone will be the inside zone. And we'll make it a little bit more specific so it's not just permitting everything. We will use the IP range of 10.0.0.0/8. So anything in the 10 subnet will be permitted to the inside zone if it's determined to be safe. Click OK. Then we need to deploy that change. That took about 30 seconds, then click OK. Another way you can see how many hit counts you're getting, you can see in the monitoring as we showed before, but you can also see it in the access control policy. If you click this button, toggle hit counts, you can see how many hits you've gotten on each rule. You can also clear the hit count. You can reset it to 0. So I like to reset this to 0 right before we do our tests. Then we'll escape this. Let's try reloading the management GUI from my PC. And it's successful. That's good. Let's click the hit count and refresh. It's got 10 hits now from the outside to the inside. So that's great. Let's check our monitoring and events. Connection. We've got a bunch from the FTD management interface to the Cisco services as before. Let's pause it. I kept searching for logs from my PC to the FTD management interface, but I couldn't find them. That's because I forgot to turn on logging in the policy. So go back to Policies, Access Control. Then rule number 2, we'll edit it. Click on the Logging tab. We will log at the beginning and end of connection. We don't have a server to send it to, so we'll send it to the FTD, click OK, then deploy that change. Click OK. We will reset our hit counts. Then let's run some tests. We'll do a ping from my PC to 192.168.1.200, which is the Firefox node. That should generate some traffic. Let's refresh this. It's got 8 hit count from outside to inside. That's good. Let's go check on our monitoring tab. Let's refresh this page. If you hold Shift and click the reload, it will do a hard refresh of the page. So it should establish a new HTTPS connection to the FTD. Let's check our connection events in Event Viewer. And we've got some connections. So we can see some are allow and some are trust. So the ones from the inside to the outside are trusted. The ones from the outside to the inside are allowed if they're determined to be safe. That's the end of this lab. I hope it was helpful and you learned something about FTD, Alpine Linux web servers, and basic NAT. In my next lab, I'll be configuring 2 FTDVs in a high availability pair using Cisco Firewall Management Center Virtual, or FMCV.